Hello, my name is Paul Merrill. I'm from Beaufort Fairmont Automated Testing, and today we're going to be talking about continuous integration and how it affects testers. So I'm going to start kind of at the beginning in the way that we used to integrate software in the past. And the way that we did that was basically you had multiple developers or people working on the code base, and they would all try to commit their code to a place and integrate it, and they would have troubles. And usually what would happen is we would have 2 or 3 months worth of work or 6 months worth of work or a year worth of work where people had gone off and done their own work on their own machines, and you come to the end of the project when it's ready to be delivered and someone is waiting on that project. They're watching their watch and waiting on that project to be done, and we get to that date when everything is due, and finally we decide as developers to integrate our code. And what happens is what you see in the middle of this slide right here, which is we have this large combustible situation where we don't know why things stopped working. We don't understand why, George over here and Paul over there and I guess Ringo and John, why when they integrated their code it didn't work and why there were problems. And so the worst part about this is that we can't necessarily tell how long integration is going to take from this point forward. So people are waiting on it and whatever. So clearly there was an issue with waiting until the end of a project or the end of a long period of time in order to do integrations. And what we found over time is that we had this new idea that the quicker we could integrate our code, the more often we could integrate our code, the easier it was to find problems, and the easier it was to rectify those problems, and then the easier it was to spend less time on them. So we found that there was a huge advantage to this. I've gone through and used a bunch of different references today, and the first one that I'm going to talk about is the Agile Testing book by these two ladies. On top there is Lisa Crispin, and the second is Janet Gregory. And they do a really good job in this book of talking about Agile testing, but getting into some of these topics as well and talking about how when you're doing Agile testing, it's almost impossible without continuous integration. And they do a very good job of talking through the problem of integration and the way that it used to be. So if you're listening to this, I'm just going to read you the first part of the slide, which says, Peril, waiting for Tuesday's build. In a traditional environment, it is normal for testers to wait for a stable build, even if that means waiting until next Tuesday. In an agile environment, if testers don't keep up with the developers, the stories get tested late in the game. If the developers don't get the feedback, such as suggestions and bugs, the testers can lose credibility with developers. Bugs won't be discovered. Developers are already on another story and do not want to be interrupted to fix them later. I think that last part, that developers don't be interrupted to fix them later, is really key. And I think it's quite a bit bigger than the way that this particular sentence is phrased. And I'm not or criticizing the way that they've written this book, because it's a terrific book, but I see that particular line differently. And my background comes from development, so from a developer's perspective, it's necessary when working on some of these problems and some of this code to put blinders on and to focus on one particular piece of software. And that's because we can only cache up so many complex problems in our brain at a particular time. So many times developers, especially earlier in their career when they have less experience, it will take a lot of effort to take that particular problem and put it into their brain, and nothing else is really active at the time. And what happens is when we wait to integrate that change, or when we wait to find a bug with that particular change or piece of code, and the developer has to go back and cache up that information again. And that context shift is very, very valuable in terms of time. It takes a lot of time sometimes to do this. I know from my experience as a developer, early in my career, it might take me 20 or 30 minutes just to understand a problem that I was going to work on that day and to get into it. And now if I'm in the middle of solving that problem and I take a 2-minute break and come back to it, it's going to be much easier to deal with any problem that I find when I come back than if I had waited 2 weeks or 3 weeks or 6 weeks or a year. Because when it's been a year, you're basically almost looking at somebody else's code. It's the you of a year ago that wrote this code. And it's very hard to detect what was going on, to remember why you did things and all of that. And I think that this is something that's overlooked in terms of continuous integration. But I think this is a really great way of talking about continuous integration and builds from the perspective of testers. So once again, I'm Paul Merrill. I'm from Beaufort Fairmont Automated Testing Services. We're going to talk about continuous integration and how it affects testers. This slide deck, this presentation is about an hour long, and it's a little bit thicker than I had hoped. So bear with me. I'm going to try to go quick. Make sure to reach out to me. This is my Twitter address here, dpaulmerrill. Make sure to follow me on Twitter. You've got our web address there, beaufortfairmont.com. Our phone number, please make sure to reach out to us. That's an American number, so make sure to use the international dialing there if you're from another country. But we'd love to hear from you. I love to talk to folks who look at these recordings. I love to get to know folks who come out and look at these recordings or attend our webinars. Also, make sure to check out our webinars page, beaufortfairmont.com/webinars, and you can get more information on upcoming webinars. You can sign up for our notifications about webinars and when they're coming out and get email notifications of them. So lots of good stuff on there. We do automated testing at Beaufort Fairmont, and what we do is we try to accelerate testing using automated testing. We believe very strongly in manual testing, that there is a place for that, and that testers have a certain mindset that is absolutely valuable, and we're going to talk about that some today. We, on the other hand, will come in and supplement in areas where teams need it in order to accelerate automated testing. So we'd love to work with problems, how to get dev and test in agile environments and things of that nature. We do that through 3 different methods. The first is consulting, so if you need to talk through your problems, whatever, I'm always open to the first conversation for free, by the way, and sometimes it's more than that, but usually it's a first conversation to talk through whatever you're going through at the time. Second piece of what we do is training. So if your team needs training with something like continuous integration, for instance, or automated testing with certain open source tools like Cucumber, or Selenium, or WebDriver, or Robot Framework, or any of these, we'd be happy to jump in and out with that, or in a programming language for testers. That's a different kind of exercise than training developers on how to learn a new programming language. So consulting, training, and the third is hands-on work. So if you have work that needs to be done, you need to bring some of our consultants in for a period of time to kind of shore up what's going on in your organization, to fill in some gaps, or to make sure to get the very best in automated testing experience in-house very quickly. We can do that. So those are the main 3 things that we do. I'm not going to go on and on about the company here. You can look at our website. Make sure to mark your calendars. I know that this is a recording, so these dates may have passed. These are all dates in 2017. Our next webinar, we try to do a webinar about once every month. The next one will be February the 13th at 1 p.m. Make sure to sign up for that. If you'd like a copy of these slides, by the way, email me at paul@beaufortfairmont.com. On the 23rd of February, I'll be out at TISCA, and I'm doing a talk there about machine learning and how machine learning will affect testing, how it does affect testing. Basically, is it going to take our jobs? And I'm doing some research about that. I'm looking to that presentation, and I'll be submitting that presentation out to several conferences as well, because I think it's a hot topic, and I think we all want to know more about machine language right now. Lots of companies using it to try to make predictions about things to come. On the 8th, I'll do a webinar with QA Symphony, the 14th through the 17th, out in Phoenix at a conference called STPCon, that's Software Testing Professionals. If you're in Phoenix, you are really lucky. This is a terrific conference. Make sure to get out there and spend that week. Go to the workshops the first 2 days. I'll be doing a workshop one of those 2 days with a good friend of mine, Angie Jones. And we're going to do the dominoes of automation, so you get to topple dominoes and set them up in cool ways and learn about automation while you're doing that. And then I'll also be doing a session there as well, talking about kind of the beginnings of test automation and how to learn test automation. The 30th, I'll be here in Raleigh. We're based in Cary, but Raleigh's right next door. Tri-Agile, which is a really great Agile conference for the Triangle. That's why it's called Tri-Agile there. 3 questions. This is what we're going to go over today. 3 questions. Number 1, what is continuous integration? And you'll see me refer to CI throughout the slides here. How do we leverage CI as testers? And are we impacted by CI as testers? So let's get started. You saw this graphic that I started with where integration worked as it used to, where we would have these terrible times trying to integrate software together at the end of projects, and the problems that it caused, and the people that were waiting on it, and the schedules that were delayed, and all these types of things. This is where we want to get. We want to get to the point where our developers and anyone who's contributing source code can integrate their software very, very well. We're all happy about it. later on. There are a few terms that we have to talk about in order to get through this presentation. The first one, and most important probably, is the term build. So you'll hear me say the word build quite a bit in this presentation. I'm using Paul Duval's definition of this really great book, Continuous Integration. And this book kind of came about after an article by Martin Fowler. You'll notice it's on the Martin Fowler signature series here. But this book by Paul Duval came about when my understanding is in 2006, Martin Fowler wrote a really great article, which I'll refer to several times throughout this presentation, on his website. And if you go out and Google Martin Fowler and continuous integration, it'll be one of the first things that pops up. Terrific article. But basically, he wanted a book written about continuous integration, and Paul Duval came along and wrote it. I'm not sure if I have all the order of events there correct, but there was a collaboration of some type there. So a build. A build may consist of compilation, testing, inspection, and deployment, among other things. A build acts as the process for putting source code together and verifying that the software works as a cohesive unit, by Paul Duval. So let's start defining continuous integration now that we know what a build is. And really, there are a couple things to note about a build here, that it has several different parts. It has the compilation part, the testing part, and inspection part, and deployment. Compilation, if you're in a compiled language, Java is kind of a hybrid, but there is a compilation phase there, so Java or C++ or lots of these languages, C#, where there is an actual compilation. A lot of people are using things like JavaScript and Python and things like that that are interpreted languages these days, and those have a compilation piece, although they may have packaging pieces involved in building a artifact for deployment. But those are the types of activities that get done within a build. So we talk about compilation here a little bit vaguely. Testing is another piece, whether that's unit tests or different kinds of tests. We're probably talking about automated tests in each of these, or we are talking about automated tests. And then inspection is the next part. So static analysis, things like that, where you're looking at the style of the code that's there to try to find and head off bugs, trying to make sure that everyone adhered to their coding standards, things along those lines. There are lots of bugs that you can find in some languages just based on static analysis, so that can be very helpful with the build. And then deployment is the final thing. How do we actually push the code out to a machine to work on? Let's define continuous integration as best we can. The final book that I'm going to, oh, this isn't from the book. This is from Mr. Fowler's blog post about continuous integration. And if you don't know who this is, make sure to look him up. He's written a lot of really great books. He's a leader in the software industry, someone to pay attention to for sure. Continuous integration is a software development practice where members of a team integrate their work frequently. Usually each person integrates at least daily, leading to multiple integrations per day. Each integration is verified by an automated build, including test, to detect integration errors as quickly as possible. I think that's a really good definition. The next one comes from Continuous Delivery. This is the last book I'll show you, but this is a terrific book on continuous delivery. And continuous integration is a necessary part of continuous delivery. So Jez Humble, one of the authors here, along with David Farley, and I may have the wrong name here, it may be Jez and David, or just David, who said this particular quote, but they define continuous integration this way. Continuous integration requires that every time somebody commits any change, the entire application is built and a comprehensive set of automated tests is run against it. Crucially, if the build or test process fails, the development team stops whatever they are doing and fixes the problem immediately. The goal of continuous integration is that the software is in a working state all the time. So there's several really key pieces here. Automated tests are run against it. A comprehensive set is very helpful. If the build or test process fails, the development team stops what they are doing and fixes the problem immediately. And there are a lot of different reasons for that. Not just fixing the problem. Some of that has more to do with ensuring motivations are there for keeping the build green, and we can talk more about that later. And then the goal of continuous integration is that software is in a working state all the time. So at every point in time, the software is in a working state. How many times have you gotten a build? If you're working in a non-continuous integration environment, how many times have you gotten a build that just doesn't work? And you're like, yeah, what are you doing? Guys, why are you sending me broken builds, right? So continuous integration tries to solve that problem, I tend to be very intentional. I like to know why we're doing things. And benefits are kind of the why in a lot of cases. So I want to talk about the benefits of continuous integration a little bit. I've got 2 slides here. I'm not going to read through all of them. But one of the biggest pieces here is rapid feedback. When we started continuous integration, it kind of came about from the developer's perspective. And we talked about that quick feedback loop, that if a developer can know within minutes, and I'm talking single digits, low single digit minutes, whether or not their code works with everyone else's, and whether or not anything is broken at a quick overrun of the code, then that's very, very helpful, and it cuts bug times down. If you know right away within 3 minutes that because of your code, something else in the code base broke, it's much easier to go in and figure out what the problem is because you know what you just changed. You remember exactly what you just changed. And when each developer is committing often, then you have John committing, at 9 o'clock in the morning, and then at 9:30 you've got Ringo committing, and at 10 o'clock you've got Paul, and then at 10:30 you've got George, and you've got these builds that run every 3 minutes, and it's very easy to segment out who did what and what broke the build usually just by the change sets alone for a particular build. You can find out what happened, and we can talk more about what change set means and what source control is and all of that in just a couple minutes. But these are some of the biggest benefits. Hopefully you've had a chance to read through them. A few more benefits here. One of the big pieces of this is accountability, and I know a lot of people shy away from that word. Fact of the matter is, without accountability, there is no success, period, in life. That's just the way that it is. If you're not going to be accountable for what you do, then there's no way that you can succeed in what you're trying to do. So accountability is not something, I know that it may have the connotation for a lot of people of meaning things related to punishment or discipline or whatever, and I know that discipline tends to have a negative connotation as well, when really the word discipline just means doing something regularly and well and detail-oriented and following a process and adhering to a process. That's what discipline is, so I'm probably going to use that word again as well, but I'd like to try to shed some of those connotations while we're talking about this. We need to know who broke a build. And we need to know that not so that we can blame somebody, although sometimes that peer pressure can really help in getting a build fixed, but in a healthy way, we need to know who broke the build so that that individual can take responsibility for it, sit down, figure out what the problem is, fix the problem, and move on. And that's important for the entire team to function. So accountability is absolutely key in anything you want to be successful for, especially CI, and this is one of the things that CI tries to bring about. If you're in an unhealthy organization where accountability is a bad thing and people aren't interested in accountability anyway, CI is not going to bring that about. But it can kind of poke a few people to get things started on that, because it's the people that make those changes, not the tool. So find and resolve defects earlier. I'm not going to read through all those, but one of the big things here is this last one, a visible state of the product. So with continuous integration, you have a very visible, very transparent understanding of the product, that if the CEO wants to look at the product, they can open up a browser and go look at what the state of the product is at any moment in time. Now, that may not be good in your environment, but in a lot of environments it is very good. The fact that a product manager can see where we are, can see if builds are breaking, can understand kind of the health and what we're going through on the team. And I'll give you a warning for some of those folks that aren't in the construction phase of development. For those people who are maybe a little bit outside of it or forgotten how this works or never experienced continuous integration as a developer for whatever reason, just because you see a bunch of broken builds on a few days doesn't necessarily mean that anything's really wrong. It could mean that, and hopefully someone at least asks the question, what's going on, and we know what's going on. But when things like that happen, there are cases where you've got to make a big architectural change, and hey, we're just going to break a bunch of stuff for a day or so. So be aware that there are different reasons that builds can be broken. It's not all. It doesn't mean that your team is just slacking. Although what we should see is green builds the large majority of the time. So if you're seeing a bunch of red broken builds all the time, chances are there's something wrong with the process in your organization, with how we interact with continuous integration and what the expectations of the team are. My lighting is a little bit different today, so you'll have to excuse me for reaching off over here. So let's get into how this works. We're about almost 20 minutes into this, and I want to get moving here. So how this works. So basically, I've got these three boxes drawn up here on the left, source code repository. So this is your Git or your GitHub or your Subversion or a GitLab or Mercurial or Team Foundation Server, those types of things. The middle one, and it's where your developers and other individuals who work on the code base put their code for storage. It makes it so that you can tell differences between one version of the code and the next, differences between one check-in and the next, so that you can see what's happening in the code base, who did what, and understand why changes are made. Hopefully that's what it's doing. But it also is a place where you merge your code and the code is stored for the long term. If you're not familiar with that, talk to your developers about it and understand what source code control is and what a source code repository is. That's a key piece of software development. The CI system, so continuous integration. These are tools like Jenkins. I think Jenkins is probably one of the biggest ones on the market right now, although I don't have the market data in front of me to prove that. But my experience has been it's one that has been out there for quite a while and has dominated for quite a while. There are a lot of really great tools out there these days, things like Bamboo and Circle CI. You can do these things in the cloud with tools like Circle CI. You don't even have to set up your own system. With Jenkins, you could go onto some services like CloudBees. I assume CloudBees is still around, but if you go Google CloudBees, you should be able to just set up a Jenkins server in minutes and have it ready to go. Now, setting up your build to work on that may take quite a bit more effort depending on where you are in your maturity as a software development organization and where you are in maturity of those particular processes. But setting up a CI system is easier than it has ever been before, and there are a lot of really great options out there for it. I did not mention all of them. There are many more. The SUT, this is your system under test. This is the place where we're going to deploy code to test it, and you may have multiple ones of these for different reasons, whatever, but there's usually some place where we can deploy code with our continuous integration system, and we can run tests against it to make sure that it works. Sometimes these are on the same physical machine, sometimes they are not. So we have these down in the bottom left. We have what I'm just showing as developers here, a little person behind a computer, and over here on the right we have these robots that are there for our test automation to symbolize them. So this is how it works. A commit is made by a developer. The source code repository, for lack of complexity and for all intents and purposes, the source code repo says someone committed. The CI system says I got it, I'm building. So she or he starts building. Then we get a deployment out to the system under test, and the system under test now has the code. The CI system says, hey, I've deployed. I'm finished with the deployment. I'm starting to test it. So the CI system kicks off automated tests, and they start testing the system under test, those robots over there. Everything passes. System under test is green. The build is green. Everybody's happy, and we notify all of the individuals involved with the code base. And that notification can happen by, these days we've got really nice RSS feeds, and Slack can use API integrations to be notified that a build worked or didn't work or whatever. You can, and you can even tie those in to telling a specific developer with a private message that they broke the build, which is a pretty cool thing to do there. Usually we'll just use email, and the CI system will send out an email. What you want to make sure of with these is that people don't get used to notifications of broken builds, and that you don't flood people with notifications to the point where they just don't pay attention anymore. So the other part of this is that there's also not just a push mechanism from the CI, but a pull mechanism, I guess, for lack of better words, where developers can just go look at whatever web page the CI system generates for builds and look at those reports and determine what happened. Did the build pass or not? But it's very important to keep this cycle here. You see a cycle here between the commit and the notification to the CI system and the notification back to the developers about the status of the build. It's very important to keep that very, very short. And I would say the primary goal with continuous integration, and this is really, in my opinion, above all other goals in continuous integration, is to keep that initial build very, very fast. Developers need to know very, very quickly whether or not something works. So we don't necessarily have regression tests or long-running UI tests or long-running, WebDriver tests running in that initial build. We want to keep this thing down to a minute or 2 minutes or 3 minutes. what I found is that people really tune out after about 3 minutes. They start doing other things. So if a developer can check in their code, go get a cup of coffee, speaking of which, and come back to what they're doing. You know, I do these things and my coffee gets cold while I'm doing them, so I have to try to remember to drink it while it's warm. But if we can keep that really, really fast, then we're in a much better spot. And I would make sure to keep that as a priority in your system. When your build gets up farther than those 2, 3, 4 minutes types of times, then it's time to start thinking about how we plan out our builds and have different types of builds for different reasons, and we're going to get into that as well. These are a few prereqs before you set up your continuous integration system. The biggest among these is probably having a one-button build, and what this means is that we can press one button and we can build the entire system. Because this system, the CI system, it is not intelligent. It doesn't know how to make a build. It can't follow a process. It can run a script. So in order to run a script, it just needs a command and it can run. And by one button build, I mean there is one command that can be run in order to build the build. Now you may take a whole bunch of different processes, you bundle them up into a script, and if you can call that script with just typing it in one time and be a repeatable thing that you can type in and hit enter, then you're good to go. And you can use that in a continuous integration environment. If you don't have that, I've been in places where the build, even in the late 2000s, individuals were still setting up builds on machines, and it was taking 24 hours or 7 hours or 4 hours to do a build. This is ridiculous. It should not be that way these days. I know that there are systems out there, and I shouldn't be so judgmental. There are lots of people who have that situation, and I want to help with that. Our company wants to help with those situations. But what I have found is that there are several things that are generally in the way of having a one-button build. One would be technical know-how. Two would be desire. People on the team do not desire to have a one-button build. And then third would be some type of regulation or a high level of risk related to the build. And people interpret that high level of risk as being best mitigated by people manually doing the build. That doesn't necessarily mean that that interpretation is correct in all cases, but those are the ways that I have seen that happen with my clients and client base. So one button build is absolutely imperative. All build artifacts in source code control, I'm using SEC here, and I realize now that I've changed terms on you, but source code control. And what I mean by this is, for instance, if you have to have an individual go in and build the tables and the schema in your database by hand, you're never going to get continuous integration to work, because the application is going to be building in an automated fashion, and then you're going to have an individual who's out there trying to keep up with builds every 3 minutes or whatever they are, and they won't be able to keep up. And so you'll have applications that do not work because the database isn't there and you're having to wait on somebody. I understand a lot of the mentality that goes into that. In most cases, the large majority of cases, what I find is when that's happening and an individual believes that they need to manually do the database work, usually what's happening is that we have a difference of opinion on roles and responsibilities. I feel very strongly that most database activities can be scripted and should be scripted, and they should be put into source code control. Now, practically that may not always be the case, but usually when I find people who want to do this manually, it's because they believe their job is to do just that. And I believe DVH jobs is quite a bit different. It's to advise and consult on how best to structure database tables, to actually write that script that gets run in continuous integration, or to advise on how those scripts should be written so that we can modify them later. How do we change the schema over time, and what should that process look like for developers to write them if you're going to allow developers to write those scripts, which can be a good thing. How do we set up performance with our databases and make sure that we've got, in traditional systems, really great indices, and we've got everything working for performance and caching working properly and all that kind of stuff. So I think that sometimes it comes back to roles on that, and if you're struggling with something like a DBA who's not interested in scripting out the tools, I think it's good to come back to kind of what is our purpose in doing this and work with management to figure out how to assess roles and figure out how roles can be and responsibilities might be able to be modified in order for this to work. So these are once again some of the prereqs, some of the practices that go along with continuous integration that are absolutely key. Is don't commit code frequently, or sorry, commit code frequently. Don't wait a day, don't wait 2 days or 4 days to commit code. Now I've done that, and sometimes I know you're working on something really ugly and you don't want to break the build for 3 days, and I get that happens. In today's world, I think that's less and less the case with people using more and more microservices and things along those lines, but you still have the case where sometimes you just have to have things broken, and maybe you have to go off on your own branch for a little while, but hopefully you can put that branch into continuous integration and make sure that things work there. So, but then you have to look at the cost and everything involved in that. Don't commit broken code. And I see the biggest offenders of these I see is either, it's usually not developers. Usually developers very quickly understand, hey, I shouldn't commit broken code, and if they've been developing for very long and have I don't really know how to say this, but basically those who have been out there for a while know don't commit broken code. Anyone who's experienced continuous integration knows that, because if you do it, everyone on the team is going to know that you broke the build, and hey, why is it broken anyway? One of the keys to making sure that works, that we don't commit broken code, is by having a private build. And that was mentioned on the previous slide. I didn't talk about it, but having a private build. And this, the thing that I have experienced that works best with this is to have the very same build that works on continuous integration available for individuals to run on their machines. And so they can run that build, run through all the unit tests or the quick running test, and make sure that they've done exactly what the continuous integration environment is going to do. That way they know before they check the code in that everything is going to be good. And avoid getting broken code. Make sure that you have automated tests. I'm not going to go through all those. So how do we leverage continuous integration as testers? And I wanted to kind of go back to what testers do. So I kind of wrote this out. And this comes from a lot of different minds, leadership minds in the testing industry. But this is my words as to what a tester does. As testers, we cannot assure quality. Many of us can't even define the term quality in a meaningful way. At best, we can identify what a system does in relationship to known intentions and report the difference accurately. We may even be able to identify risk associated with the differences we find. Further, we may identify what were previously unspoken intentions and illuminate them for the organization. That's what I feel like a tester does. So when I talk about testers from this point forward, that's what I'm talking about. Now, you and I can sit down. I'd love to spend time debating this particular definition of what quality is. But I don't really believe that I can deliver quality. I don't know how to do that. If I called you up and said, "Can you deliver me some quality today?" I'd like to see what you showed up with. I just don't think it's something that we can deliver. I don't know that it's even something that we can measure. We can measure whether a product does what we intended. We can measure things like that. But the aspect of quality is really very, for the most part, arbitrary. And so what we're trying to do is figure out, does the product do what we intend it to do? Does it do anything else? What is the risk associated with that? And the most important part of our jobs is how we report that back to the organization. So I wanted to talk very briefly about the concerns of testers and developers so that I can kind of identify the differences between us and why we look at continuous integration and other parts of the development life cycle differently. Number one, I think testers tend to look at the status of the entire product, and we talked about developers necessarily needing to keep the blinders on to focus on a very difficult piece of code. So they're looking at the status of a particular change. They're not necessarily looking at a product and the status of the product as a whole. The fulfillment of intentions is where testers come from. Do these requirements match what came out? Does this story match with what came out of the development time, our iteration, or our sprint? The completion of well-defined tasks is more where the developer is. The developer is tasked with finishing tasks, with completing work items. It's a very different thing than poking at work items without the same pressures and saying, okay, I want to see what I can get it to do. It's a very different mindset. And these are necessary, and this is why we need different people in these categories, because we need people who focus on these things on the left, and we need people who focus on these things on the right, and we need for their motivations to be different in order to get what we want out of them. I think sometimes it's very easy to look at things like hey, I'm a developer, and the way that I look at things is right, and the way that testers look at it is wrong. Now, if you're colorblind here, this is going to be a problem, and my apologies. But on the right, the developers are in the green here, and on the left, testers are in red, and so it's very easy to look at it that way. And then I switched these up and said, well, if you're a tester, it's very easy to look at these things that we think are important on the left, and the green on the left now, and think that they are very good things, and the developers are all wrong for the way that they work and the way that they do things. And really, I don't believe that's true. I think that we're all there to work together on these products, and we've all got our motivations and our intentions and our influences about us that are pushing to work in certain ways and to aim at certain goals. And when we factor in continuous integration, what I wanted to do was to say, how do we look at these particular motivations in terms of continuous integration? So I put together this chart and said, which are the things that CI can help with and which are not? So in the red here, I've got exploration on the left, exploration, error finding, and on the right, removing gaps, real versus requested completion, coherence, definitions. All of those in red basically saying continuous integration is not going to help with those. Okay, the things in green here, all the other things, are the things that continuous integration can help with. And some of these might be debatable, and I would love to have those conversations with you. So I said, let's just gray out the ones that we can't take care of, and let's focus on the ones that we can, and then which ones are the ones that are the easiest to be helped by continuous integration with. Sorry, that sentence was a little bit jumbled there, but how does CI help us the most, and which of these does CI help us the most with? So the state of the product, knowing what the state of the product is, provided you have a robust set of automated tests and you can run them often in continuous integration, then yes, absolutely, you can tell the state of the product. Same with the status of a change, provided you have a robust set of unit tests. That probably means that robustness is different at the level that the developer needs to run in 3 minutes versus what the tester wants to see run in an hour, or doesn't care how long they take, right? Because our motivations are different. Fulfillment of intentions, I think, is something that sometimes we can do. So the lighter green here are the things that we may be able to figure out with CI. And the lighter the green, the less likely we are to figure out. Finding gaps, real versus requested, provided you have a really good set of tests that are aligned with what's requested and show you what's real, then yes, we can identify gaps in the system with those. Really, most of the work there, though, is done by the writing of the test cases by the individual. It's not the CI system or the test that finds it. So I've left that a little bit lighter there, but I just wanted to give you some to think about. So I wrote down some of the bigger categories of automated tests, and on the left I kind of have broken down my structure on the right by risk assessment. And if you're not familiar with these, you can get familiar some other time, but really what I wanted to do was I spent some time with Ryan working on a presentation that I mentioned earlier, and we came to the conclusion that when we're managing test cases for CI systems, we tend to factor in two main attributes or two main ideas, and the first is risk. So many times when we're allocating test cases to builds, we allocate based on risk. We want to know, are the riskiest things taken care of? And we'd like to know that as early as possible. As testers, we would like to know that as early as possible. We'd also like to make sure that runtime is dealt with. So how quickly do these test cases run? So just because you have a test case that shows you a very high-risk operation doesn't necessarily mean it should be in that initial build that takes 2-3 minutes or 1 minute or whatever. Because what if the test case 10 minutes to run? Now your developers wait 10 minutes and they're going to get antsy and go start working on the next task and forget all about this one. And it's going to take longer for them to get back in, or they're not going to get back in because they don't, like Lisa and Janet said, they don't want to be interrupted. I think that both of these two things are big factors. So what I've done is taken the tests on the types of tests on the last slide and mapped them to this chart. And the way that I'm thinking through this is a hypothetical application, okay? This is not the same as the way that your application is, but in some cases, maybe this is true, okay? So I would not say that in all cases, all E2E tests have higher runtime and kind of medium level risk. That's just not true. Many times an E2E test can find things that, or can ensure things are going on, that changes have been made that are high risk items, okay? So that could be very, very high in your situation. But in this hypothetical situation, this fake situation that I've made up, I have these out there in a way that seems to be reasonable to me, okay? Most of the time unit tests are very, very fast. Sometimes functional tests might be fast. Integration tests might be fast or slow, but they might show a higher risk item, like the code not integrating at a deployed type of level. This particular service not working with that one, for instance. Whereas a functional test might show you that something new isn't working, and maybe that's a lower risk in this particular situation. So try not to be bothered too much by how I have thrown these up here. You should probably do this exercise with your team and draw this diagram up on a whiteboard and these different types of tests and say, what are we running when right now? How do they map to this diagram? And does that make sense? What I wanted to do next was kind of say, how do we manage our builds? So many times within continuous integration, you've got not just one build, but you've got multiple builds or multiple jobs going on. And those can be linked, they can be dependent on each other. So for instance, you might have three types, you might have three types of jobs here. You might have one that gets done per commit or per push. You may have one that gets done on an hourly basis, so every hour it runs, and you may have one that runs every night. And for this particular organization, maybe it makes sense to do this way. So in this case, maybe they know that their smoke test plus their unit test can run in 2 to 3 minutes or 4 minutes or 5 minutes or something like that. And so they put that in the commit hook version of the build. So that particular part of the build gets run every single time there's a commit. But on the other hand, they know that their functional tests and their service tests and their integration tests, when all put together, take 15 minutes to run. And while they provide a significant amount of information about the level of risk of this new product and risks that we've introduced with new code, it doesn't necessarily that risk alone may not be enough to move these particular types of tests into that first category. In fact, they may take so long to run that we need to run them in an hourly fashion. So maybe in this case, they've got those three types running hourly. And then finally, maybe your end-to-end tests take 4 or 5 hours to run for whatever reason. You've got to run over 10 different browsers and 3 different mobile apps and whatever. So every night we're going to run a 4-hour build, and when we come in the morning, we'll know what part of that worked. So here I've got this split up into 3 different jobs. There are also other ways to do this and things that you should think about. If you're going to run this nightly build, you should still run the commit tests and then the hourly tests and then the nightly tests, okay, in this particular scenario. And the nightly test should not run unless the hourly tests pass, and the hourly test should not run unless the commit tests pass. Because why waste the time, right? If you've got something that failed in a unit test, why waste the time of running all this other stuff? So I think that that's important to note as well, that we always do the lower level type of test with these. And there are ways to do that with each of these CI systems to say, basically, if the last part of the job did not pass, then don't do this part. Or if the last part succeeded, then let's make sure to do the next part. So are we as testers impacted by continuous integration? And I think the answer is yes, but what I want to get to really is the fear that I have seen in so many people's eyes related to new technologies, new processes, things like continuous integration. And I wanted to try to lessen that fear, mitigate it if possible, by just going out and talking about these things that are really hard to talk about. Now, I'm going to tell you, I've never seen a single tester lose their job because of the implementation of continuous integration. I'll also tell you, I've never seen a tester lose their job because of the introduction of test automation. So I think that's something to really consider there. I've never seen that. And when I say never, I'm talking about dozens and dozens of clients, projects, clients, companies, teams that I've worked with over the years, over 17 years. And now I'm talking about even in interviews. So I probably do 3 or 4 or 5 interviews per week now with potential customers and with people who just want to get information from me and who want to get some advice, and I'm always open to that, like I mentioned earlier. So make sure to call us or to email me, paul@beaufortfairmont.com. You just want to talk through whatever problem you're having. But I have those conversations, and what I get from them many times is, number one, I can really help out people many times. So because I've seen all those different instances of this and seen test automation work and not work in a number of different, quite a large number of different clients and projects and whatever over time, I can share those experiences with you, and you don't have to go through the bumps and bruises of learning it on your own. But even in these conversations, sometimes I'll ask, hey, look, you guys introduced continuous integration. Did anybody lose your job? And now when you're doing this 3 and 4 times a week, how many different groups am I interfacing with? Plus every conference that I go to, you know, I would like to know this. I've never had anybody come up to me and say, hey, look, we introduced continuous integration, and then they fired all the testers. I haven't had that. I haven't had that happen. I have heard of I have heard of, from time to time, when a large suite of automated tests has been built, management considering lessening the number of testers there. But that's something that is really a ridiculous thing to do, because when you've got that suite there, you have to maintain it over time, and who has to maintain it, and then who are the brains behind how the test cases were written in the first place? So I argue very strongly against that when I come in and work with organizations. I think that it's very important to have individuals who are testers, who work in this particular practice, this discipline, and understand how to do testing. They are the ones that should be most involved in test automation, that should be helping drive it, that should be helping inform what we should test and how we should test it along the way. And they're the most important people later on, because what tends to happen is when you introduce test automation, you actually end up with more time to think about more things as a tester. So all the test cases that you used to do by hand that were easy for you and that you didn't have to think about, those are gone. Something else is doing them. And now you've started thinking about, well, what about this more complicated case? Well, now I can start to understand the domain more. Now I've got more time to go out and talk to product owners and learn how the product works and what the customer is doing with it to an even deeper level. And that is much, much, much more valuable to an organization than pushing buttons to run test cases or clicking mouses to run test cases. I think that's the true job of a tester, is to think deeply about the business and to help the business move forward in a way that is in line with their amount of risk that they've accepted. So that's kind of where I come from on that. Should testers fear CI? My answer is absolutely not. In fact, I've seen a higher level of quality come out of this in nearly every case. I've seen, yes, you may be handing over some control about when test cases run and how they run. Anytime we have that situation, the fear that comes out of that is usually about education. So if there's insight into what's going on in the process, if there's insight into the scripts that are run or whatever, that can assuage those fears that one might have in handing over that control. So transparency in how that works rather than saying, yeah, it's going to work. Like if I'm a developer saying, oh, we scripted all that, you don't have to worry about it anymore. People want to know why it changed and why what they used to do is working now and how it works, and they want to make sure that it works like they believe it should, and they're going to be skeptical of it because they're testers, and that's just the way our brains work. So is it hard to learn CI? No, you're spending an hour learning about it right now. It may be hard to learn how to make your builds work, and that's certainly somewhere where we could come in and help out and talk through with you, or actually do the work for you. Fear of the unknown is something that we all tend to have, and it's there for good reason. But just because something's unknown doesn't necessarily mean we should fear it. And hopefully, this is a little bit of education about CI, and we have a little bit less fear of it moving forward. A tester's experience in CI. So what I see the most is I see there's more to test. So if you're creating a new build every 3 minutes or every 1 minute or whatever, there's a lot more there to test. And that means that we have to use more automation because we just can't manually go in and run a gazillion tests in 1 minute. We have ways to automate that. You've now got a moving target testers. So we have this continuous stream of code and application coming out of our development group. And that means that we have to be able to test that. We have to be able to work with that moving target. We've got quicker assessments of the state of the system. I think that this experience really ends up being a great thing because the testers reach into what they can do and their abilities increase, because as a tester now you're looking at reports of what test automation did and trying to understand what's going on with the system, and you're more in line with what Ringo and John did yesterday as opposed to what they did 3 months ago. And we can bring that information back to the team and help out with it. Plus, we can introduce new tests and they're persisted in an automated testing fashion, and we never have to think about them again, provided we build them in a way that is low maintenance to begin with. So testers who should avoid CI, and I'm not trying to be judgmental about any of this, I'm trying to just say, look, these are folks that I've run into and they're ones who should avoid CI. So if people like to run manual test executions, well, we're going to be moving to test automation more and more when we have CI. Now, that doesn't mean everything is tested by automation. There's still a place for manual testers, but the work that's going to be done is not going to be very repeated. That may be, in some cases, you may have things that have to be done manually because maybe it's really costly to automate. But in general, you're not going to be manually running tests as much anymore. We're going to try to lessen and lessen that so that our CI can tell us more about what's going on in the system rather than humans having to test it. Instead, testers are going to do more exploratory testing, more thinking about the system, more trying to set up very clear test cases that give us good information. People who think testing should slow down deployment. So there are people out there who believe this, and they believe it for a very good reason. In their experience, it makes sense. There are places where risk is incredibly high related to a product that's being put out. Maybe lives are at risk, and maybe just the idea of a risk, just the idea of testing something, just the idea of thinking through, is there a problem, is enough to slow the deployment. That's perfectly fine if that's where your company is, but you may, or your team is, or your product is, but that may also not be a good place for continuous integration. It may or may not, but in most cases I'm going to say it's probably not. Philosophically opposed to test automation, there are people who are just adamantly against it. That's fine. Their experiences have led them there. Those are not the people that you want in charge of continuous integration. They're not going to be in support of it and not going to try to make it work. So make sure that you know who it is you're getting involved here. And if these are things that you need to change in your organization, these are just items that are baggage coming over from a previous job, and in your particular situation it's not accurate, then some education, some talking, some understanding of where people come from can be very helpful with that. I want to talk a little bit about roles. These are some of the major roles that I see here. Triage is probably the one that people don't know the most about, but if you have somebody on your team and you've got a nightly build, somebody who comes in at 7 o'clock every morning, you know, every team's got that one guy that comes in at 6, 7 o'clock every morning, and they want to leave by, 4 or whatever it is, 3:34, for whatever reasons. But that individual is usually a very good one because of timing to be able to triage your build. So if you have a nightly build and it breaks, what you would very much like is as early as possible to know the most that you can about that build. So that individual that's coming in early, provided they are able to troubleshoot and understand what's going on with the CI system and kind of can drill down into some things and at least make sure that we know why something broke, we understand what's going on with it, and we're ready to address it first thing in the morning. That can get the day moving so much faster. If you have to wait until that individual comes in that broke it at 10 o'clock in the morning and everybody else is already there, everybody's kind of waiting on that one person to get the day going. And at least if you know early in the day who it is, and that's that guy that comes in at 10:30 every single day or whatever it is, then you can say, look, that person's not going to be here. I'm going to jump in and fix this at 8 o'clock when I get in. It'll be done. We can all move forward, and I'll talk to them about it later, right? So I think those are things to consider in terms of speeding up your environment using CI. So really, we wanted to answer these 3 questions. What is continuous integration? I think we did that. This is the practice of integrating code continuously throughout the day, having lots of commits from your developers, having a very tight cycle, feedback cycle for developers in understanding what's going on with the system. How do we leverage CI as testers? Well, I think as long as we keep that priority of that quick feedback loop for developers there and keep that ability there, the way that we leverage it is to be able to add our tests in to other types of builds and other types of jobs that get run with CI, and maybe they run periodically because they take longer. Maybe a few of those test cases move into your very quick, fast on-commit build. Maybe some of those are a nightly build or whatever. I've had situations where at one particular client we had a very, very large suite of user interface web tests, and they had to run on many, many, many different browsers, and we had that on bare metal in our facility at the time. We had not moved to cloud. Some of these services like Sauce Labs and whatever were not available, and that system had other constraints over the course of a night, so we couldn't necessarily run everything in parallel. So it might take 10 hours to run. So in that case, with a 10-hour run, if it went wrong and needed to run again just to see what had happened, then we really thought this would be best to run over the weekend. So we would only run those over the weekend. Then we had other builds to make sure that we could identify what was wrong in the system as early as possible. We had an hourly build and we had a nightly build, but to have one run over the weekend was very important for us in that case. So as testers, we can leverage this in a number of different ways to find out the state of the product and to be able to report on it. Are we impacted by CI? Yes, we are. Our jobs change to some degree. You're still going to be, as a tester, looking at what is going on in the system, what's the state of the system, how does it work? And the better you are at that particular job, the better you are at going along with the way that the organization is going with some of these new practices that are very proven. And by the way, CI is not new. It's been out. I first used continuous integration in 2002. But the way that we work together to make these things happen is absolutely key, and you'll be really, really valuable if you can take advantage of automated tests, and even if you're not the one writing them, to be able to go in and look at the reports and figure out what's going on in a test, or to be able to advise in how they're written, or the ways that we design tests, or the things that are important to look at. All of that is very important, and you'll make yourself more valuable by looking into that, and by using the fact that you're not running as many tests anymore to focus on other things like learning the industry, learning the domain that you're in, learning that business problem that your company and your product is trying to solve. Those are absolutely important to organizations and very, very valuable. I've used a lot of references. I have 3 different reference pages here. You're welcome to email me if you want to copy these slides, paul@beaufortfairmont.com. I talked about a lot of these different books. The one from Kent back up there, I didn't have on hand, and I didn't look up for references, but I'm sure a lot of my thinking comes from that book, as well as some of the others on here. There's a market paper down here at the bottom that I got from CA. The references here, a few more that I mentioned. I think it's always good to look at other people's perspectives here. So 1 or 2 interesting articles by this Yegor Bugayenko. I'm not sure if I said that name right, but he's kind of a leader in the software industry these days and has some thoughts on the other side and why continuous integration doesn't work. And one of the main things that it comes down to is that it's very easy for the system to be in a state of red. And I've been at that place, and when the system is always in a state of red, people stop caring about it, and he's absolutely right. That is what happens in those cases. So it's very important, if you want to make this work, to make sure that your test cases are reliable and consistent, that they are not brittle, that they fail for one and only one reason, and you can determine exactly why they failed and troubleshoot things very, very quickly, that they don't fail because of problems with test automation, and that they are in a green state, and that they are truthful about what they're displaying to you in that greenness, for lack of a better word. Those are the things that work with that. The references, I also had a couple other references here. These are the icons that I used, and I get them by permission from the Noun project. And these are the artists, the graphic artists, I guess, who wrote these up. And I really appreciate these folks spending their time doing this, and I love using them. This is my information. So I love to talk through what you're doing with your test automation, whether it's succeeding or failing. I want to know how you're doing, what you're doing, why you're doing it, what's going on in your organization. I love setting up time to talk through with people with what's going on. Many times we can have a quick conversation, and there are things that I can add in just a few minutes that can add a huge amount of value to what you're doing, and shorten your times in how you're doing your test automation. For instance, the other day I was talking with someone about GUI, their GUI tests, their web automation tests, and some of their setup would take a very long time, and all the tests had to run through the same setup, or they had set up in one test case and every other one was dependent on it. And I said, well, you just mentioned an API. Can you do that setup through the API? And she says, yes. What a great idea. So things like that can really save a lot of time and effort and code, and get code out of your test automation because we want to maintain as little as possible. So I've got a podcast called Reflection as a Service. I try to put those out on the 1st and 15th of every month. It's about software development and entrepreneurship. And we look at entrepreneurship from the software developer's perspective because that's my world. I write on testing and test automation at beaufortfairmont.com/blog. I try to write about twice a month on there, although last year it looked like it was only about 15 times out of 12 months. So sometimes I get more time to write than others. You've had my email address, paul@beaufortfairmont.com. Make sure to follow me on Twitter, Paul Merrill, Paul Merrill. I love talking to you guys. I want to get to know you. If you're recording this, I want to know who you are and what you're doing. So shoot me an email. Let's talk more. If you want to copy these slides, I'd be happy to give you more. Remember, the next one is in February on the 13th at 1 p.m. Make sure to go sign up. Go to the beaufortfairmont.com/webinars page, and you can find that information on whatever's coming up next. So thank you so much for your time. I hope you learned something, and I look forward to getting to know you.